So these directions are the same as yesterday where we ended up. Evaluating compositive trig expressions. I want to start with where we ended because it's now going to be a little bit different. So we have a composite of functions. We're supposed to do the inverse tangent first. So I'm going to write for inverse tangent that so that is the ratio, that is the opposite over adjacent. What I'm looking for is the theta answer. So my theta has to be between pi over 2 and negative pi over 2. No calculators. So this is going to be a quadrant 1 answer. So I might as well just sketch out a quadrant 1 triangle. And it's this theta, right? That's going to equal a theta. That's going to equal an angle measurement. I'm trying to figure out what angle measurement. When I take tangent of it, I get a 5 is an opposite and 12 is an adjacent. So there's my theta. That answer is that theta there on that triangle. The inverse tangent, whatever degrees or radians that is. I don't know what it is, and what if I can't use a calculator? I'm not supposed to use a calculator in this section. So I know that's the theta. I just don't know how big it is. I don't know if it's like pi over 3 or pi over 7 or pi over 12 or 7 pi over 12. I don't know what it is, but I know it's that triangle, and I know it lives in quadrant 1. So here's the theta. I'm going to put that theta there in that parenthesis. I know it's that theta. That's the answer, whatever that theta is. I don't know what it is. I don't know. But that theta right there. So I'm going to take the cosine of that theta that I don't know. What's the cosine of that theta? Well, cosine is adjacent over hypotenuse. So what would that be? 144 plus 25 equals hypotenuse squared. So that's a 169. So that's a 13. So I guess the cosine of that theta that I don't know what it is 12 over 13. Did I ever really answer that middle one? No. Did I draw it out properly? I did. I have to draw it out properly. I filled in all of the sides using Pythagorean Theorem, and then that theta is that answer to that, because that's what I'm finding is a theta. So I just wrote it there, and I know it matches that one right there. So I just took the cosine of that theta that I don't know what it is, and it's 12 over 13. That I can answer. Let's try it again. So my first one is an inverse tangent, so I know it has to fall between here, my theta answer. I know this is a positive ratio, so it's up here in quadrant 1, so I just might as well make that quadrant 1 triangle because I don't know what that is. So I'll put my theta, and the 3 would be the opposite, the 4 is the adjacent. So sine of whatever that theta is. I don't know what it is, but I know it's a quadrant 1. I don't know what it would be, something less than pi over 2. Now I'm supposed to take the sine of that theta that I don't know what it is. So that's opposite over hypotenuse, so that's what? 16 plus a 9, hypotenuse squared, so that's 25. So that would be a 5. So that would be 3/5. Would you like to ask anything, or is that my yes, please.
I don't understand why you write that little half circle.
The theta. That's a Greek letter. It's called theta.
No. The pi over 2 and the negative pi over 2.
You were not here yesterday, right?
No.
Ah. Yesterday. You missed a lesson. Go on YouTube. 35-minute lecture. At least it's got somewhere to go, right? You can listen to the whole 35-minute lecture they had to listen to in class yesterday. And then you can come back tomorrow and tell me about it. Next. First thing I have to do is an inverse sine. So for sine, for those of us who were here yesterday, we know why I'm writing this. Sorry. I'm sorry. I know. And so I have to do inverse sine first. So this ratio is negative, so I'm really down here in quadrant 4, correct? So I don't know what the inverse sine of negative 1/3 is, so I might as well just make a quadrant 4 right triangle. And let's see, sine is opposite over hypotenuse. So the negative 1 is here because my hypotenuse is always positive. Did I do that right? Oh, and that's for this theta. This theta that I don't know what it is. Cotangent of that theta. I mean, that answer is this theta here. I just don't know what it is. So the cotangent of that theta, what I need for a cotangent, I need a adjacent over opposite. Oh, I need this. So I'll just do Pythagorean Theorem again. So a squared plus negative 1 squared, which is 1, equals 3 squared, which is 9. So a squared equals 8. So a equals 2 square root of 2. So let's see, what do I need? Cotangent is 2 square root of 2 over negative 1, which is negative 2 square root of 2. Talk to me. Why don't you like it?
Oh, no, I'm just saying that.
Oh, okay.
I get it.
Okay, good. You don't have to like it, you just have to get it.
That's.
Let's do one more. And my first one is my inverse sine. I guess sine and tangent. This shape here is a popular shape. So let's see, that's a negative answer. Again, that's down here in quadrant 4, so I might as well make my quadrant 4 right triangle. This answer is going to be a theta. It's that theta right there. That's that answer. Let's see, so that's a negative 1 over 2. So cosine of that theta there. So cosine is adjacent over hypotenuse. I got to do Pythagorean Theorem. So that's the hypotenuse, 4 equals negative 1 squared, 1 plus a squared. That'll be my a. So that'd be 3 equals a squared. So a equals square root of 3. So cosine is square root of 3 over 2. Is that okay? Are you okay with that? Okay, now I'm going to take this same idea and I'm going to add variables into this.
Oh, just make it harder.
Welcome to mathematics. Because it's got variables, the best I can say is to simplify the expression. I can't solve it now. Before, we're actually giving me a numeric answer. Now, because there's going to be variables, the best I can tell you is to simplify the expression. So first thing I'm going to tell you is to assume x is positive. So all the x's that you see are going to be positive numbers. We don't know what they are. Just want you to assume it to be positive. So instead of 1/2 or square root of 3, I put an x. There's no numbers. Yay. Inverse sine. I know I'm restricted here. So what is x? Is it positive or negative? So it's going to be quadrant 1. Sweet. Let's draw a quadrant 1 right triangle. So this answer is a theta. That's the ratio of opposite over hypotenuse. That's what this is. So this answer is a theta, that theta right there. So in fact, I'll write it. This answer to this is that theta. So let's go, in fact, I'm going to make that a fraction so you can see the opposite over hypotenuse. Opposite over hypotenuse. Well, I want to take the cosine of this theta. Well, that would be adjacent over, oh, I need an adjacent. I better go do Pythagorean Theorem. So that is this side, x squared plus, we'll call this one a squared equals 1 squared, which is 1. Well, I want to know what this side is, a. So let's just solve for a, like I just did before with numbers. So let's see, I'm going to solve for a. So a squared equals 1 minus x squared. Now I take the square root of both sides, and I only want the positive answer, not the positive and the negative, because I'm dealing with the real triangle here. So a equals the positive 1 minus x squared. Oh, that's the length of that side. Cool. Now I can finish this. 1 minus x squared?
What if that 16 squared times x squared?
Okay, so let's take the cosine of that triangle. What is it? Finally, a cosine, an inverse cosine. I get to draw the other shape. So I know the answers have to be here. So positive and negative. So is that 2x positive or negative? Positive, because I'm supposed to assume all x's to be positive. So positive times a positive, so I'm going to live in quadrant 1. I'm going to draw a quadrant 1 right triangle. This answer is a theta. It's that theta right there. I'm going to take the sine of that theta that comes from here. So this, I can go ahead and do that. It is an adjacent over hypotenuse. But now I'm supposed to take the sine. I need an opposite. So I need to go do what to this? Pythagorean theorem. So my hypotenuse squared equals 2x quantity squared plus a squared. That's 1 equals 4x squared plus a squared. I'm going to solve for a because that's this side length. So let's see. That would be, I'm going to solve for that. So 1 minus 4x squared equals a squared. A equals the square root of 1 minus 4x squared. And no, I cannot simplify that any further. So no, sine is going to be this over this, but since it's over 1, it's just going to be a square root of 1 minus 4x squared. So all I'm doing is simplifying. I actually can't come up with numeric answers because I have variables. I have 3 more of them for us to do. And then that's it for today. Oh, good. We got a secant in here. So I do my inverse cosine first. Since it's the inverse cosine, I know that my answers for my theta are here, positive and negative. I'm supposed to assume all x's to be positive, so this is going to be a quadrant 1. I'm going to draw my quadrant 1 triangle. There's this theta, because the answer to an inverse trig function is the angle measurement, my theta. So cosine is adjacent over hypotenuse. Adjacent over hypotenuse, correct? But for secant, let's see, for secant, what is that? I'm going to write the reciprocal. Isn't that 1 over cosine theta? Oh. I don't need to do Pythagorean theorem. So not all of them will you have to go ahead and complete the whole thing. Go ahead and just write what you have and then look and see what you need to see if something is missing. If it's missing, finish it up with Pythagorean theorem. If it's not missing like this one here, then why bother doing work you don't have to do? Inverse tangent, that's what I have to do first. I have to assume all x's are positive, and that's already positive, so that's still a quadrant 1. The answer to this is a theta, this theta right here. Tangent is opposite over adjacent. Better make sure, see what I need. Cotangent of theta is just an adjacent over opposite. I didn't have to do any more work.
I like this code.
Last. I have an inverse trig function, sine, that I must begin with. Let's see. That has to be positive, so actually all answers to square roots have to be positive, and that's positive, so that's going to be my quadrant 1 one more time. The answer to an inverse trig function is my angle measurement theta. It's going to be this theta here. I don't know what it is. I don't have to solve for it. And the sine is opposite over hypotenuse. So opposite over hypotenuse. It wants me to do cotangent. Cotangent is adjacent over opposite. Oh, I have to finish out my Pythagorean theorem. I have to finish it out. So there's my hypotenuse, x squared, equals hypotenuse. And then this side length will be called a squared, and then I must grab this other side. So this is still my x squared, that's an a squared. Tell me what this is going to be. X squared plus 9. Why? This is the same thing if I put parentheses around it and put 1/2 power. And then I went and I squared it. Power to a power, you multiply them. 1/2 times 2 over 1 is 1. What's it? Oh, yes, thank you. Minus. What am I solving for? I'm solving for a. So I better gather up the x's first. I'm going to subtract this x squared over here. It goes away. And I'm going to add 9 to both sides. That's a 9. That's an a. Now I'm going to take the square root of both sides. I only want the positive answer. I actually got a numeric answer for that. Yes, sir? You tell me what I did with it. Do you see what I did? That's correct. That's correct.
So just the x squared and you left the 9 there?
Well, I was just doing one thing at a time. This is what I do. I mean, for me, I go really, really slow. I take one thing at a time.
Yeah, but I thought you would take it together as one term.
Ugh. You might, I don't. I go really slow.
No.
I just see 3 things there. I'm going to take one at a time and go over there. I wanted to get all the x's together first, so I subtracted off that x squared. I wanted to finish that off, and then it just like went away.
Yeah, no, I thought about taking it as
Yes?
Why the only the positive?
I don't, because I'm on a right triangle. I want positive lengths. And I'm in quadrant 1. I know all the side lengths are positive. If I was just doing math without doing a real life picture, just math, you have to put the plus and the minus. When you don't know what you're applying it to, you have to have all of the answers. But because I'm applying it to something that I know has all positive answers, I only need to choose the positive. Thank you. Anything else? Great question so far. So I put the 3 up there. Now I can finish answering this. Cotangent of this theta is adjacent over opposite. Oh, I'm technically not supposed to have a square root in the denominator, am I? So I'm supposed to multiply by that. It's a special 1. So this square root times this square root, yes, sir.
Shouldn't 9 be negative?
Don't I have negative?
No,
No.
Here
Oh, it's just.
it was positive, now it's negative. It was negative, then it was positive. Yes? Okay. Tell me about the square root times the square root. Cancel them out, so what am I going to write in the denominator? X squared minus 9. Then 3 times that is just 3 times that. One's on the outside, one's on the inside. Call it a day. Ooh, that's it. Ooh, cotangent theta, sorry.